Top Med Talk.
Nick Harrison here. Welcome to Top Med Talk. This piece is taken from the Perioperative Medicine Shared Interest Group's 2018 annual conference, Measuring, Managing and Minimising Risk, which was held in association with the Australian and New Zealand Society of Geriatric Medicine and the Internal Medicine Society of Australia and New Zealand. Don't forget to check out the show notes on topmedtalk.com for more details. Have a listen.
On the app. I'd like to introduce Doug Campbell. Doug's a specialist anaesthetist at the Auckland Hospital. Originally from the UK, went to New Zealand back in the early 1990s, so I guess it makes him pretty much a Kiwi by now. If he's not integrated yet, he would never become integrated. He's got strong clinical interest in neuroanaesthesia, but more importantly, he's unique in the respect that he's got a good statistical and epidemiological background and strong with respect to mathematically modelling. And he's going to present for us now. Thank you, Doug.
Thank you very much. I'd like to emphasise that I'm a clinician. I spend 90% of my time either in theatres or in the pre-surgical assessment clinic. And I'm going to be talking about risk prediction tools. And this title was given to me by sort of Jill Van Acker, but I think it highlights the issue. I think we're looking at we all use and study risk prediction tools, but I think before I got involved in this, I really didn't know how to decide which one I should be using in which circumstance. So I hope by the end of this talk there'll be a bit of light shed on the matter. I don't have any direct conflicts of interest. This was funded by a research grant from Precision Driven Health. I'd like to acknowledge my research assistant, Luc Boyle, who assisted in this work, the support of my department, and in particular people like Jay van der Westhuizen, who's here, and the rest of my department. And I will be talking about the online risk calculator later on, that is the product of work by our current perioperative fellow, Dr. Kate Hudig, who's also here, and a colleague of mine, Martin Mazur, back at Auckland City Hospital. This was a review by Ramani Mooning-Singham that was done a few years ago, looking at risk stratification tools. And I'd just like to take issue right at the very start. These prediction tools do two things. They stratify, but they also predict absolute risk. So they do more than just stratify. And we will, as we go along, we will show what these tools do well and badly in particular circumstances. And if you look at this article, there's about 48 non-cardiac risk prediction tools they looked at. So this is a very complicated slide that I don't want you to go through in detail, but it's just going to highlight a few issues. Some fairly punchy acronyms down the left. The second column is going to be the number of variables, which is either going to be very high, some of them have 18 or 20 or 24 covariates, and some with very few. This table is just from studies where there's been multiple external validation studies. One thing I'd like you to pay particular attention to is the sample size of these studies. So in order to validate or a prediction tool, the first time you do it, you're going to need about 100 covariates, 100 events per covariate. That means deaths. If you're going to externally validate it, you need about 10 for a logistic model. So if you've got a model with 10 covariates and you want to externally validate it, you still need 100 deaths. And if the average 1 month mortality, it's not as high as 1%, but let's make the maths easy, is 1%. That means you need a sample size of 10,000. So if you're going to do the first, lots of exploratory covariates, we're really talking about sometimes a sample size in the region of 100,000. What we're looking at here is a bunch of pilot studies. Right? I want to emphasise how small the sample size in these studies. They are not sufficiently large to give you a stable model. The inclusion criteria are highly variable, and the statistical properties are a bit arcane. We'll go through that in a bit more detail in a few moments. So within this group, there's going to be people who want a risk prediction tool that has more and more and more covariates. I'm going to call you the splitters. And there's going to be people who want, just give me something quick and simple, a few easy collectible features. You're going to be the lumpers. All right? I include myself as a lumper. I like quick and easy. And this is part of the mythology of individualised prediction, that, you can personalise this prediction. The more detail you get, the more likely you're going to get to the truth. Well, this is the as good as we can get. Mrs. Smith here, she's alive, bang, there's her mortality is 100% on day 30. We're not going to get to this stage ever. You're going to have to get used to the idea this is a probabilistic exercise. You're going to be dealing with probabilities. You're going to be dealing with uncertainty. And at the end of it, you're going to have to explain it to a patient. I don't actually understand this stuff. You're going to have to tell a story. So, I'm standing up here as the numbers guy, right? When I use these tools, I tell a story. All right? I'd just like to emphasise that fact. So we're going to start with, how do you validate a risk prediction tool? For those of you who are particularly interested, I would recommend this paper to you. It's a very easy read. It's read by pretty much the guru of risk prediction tools, and tells you, what steps do you need to go through. The first step is choose the endpoint you're most interested in. Now, we're going to be talking primarily about 1 month mortality. Although pretty much every risk prediction tool I've just shown you on that previous slide uses 1 month risk prediction. Is it actually what we're interested in? Now, on the top right there, you can see something from a separate piece of work that I've done, which is showing the hazard of dying after surgery. And it's quite small, but I'm going to tell you that those numbers at the bottom are months. So you can see that for many surgeries, the excess risk of surgical mortality carries on for far longer than 1 month. So 1 month's mortality for our higher risk patients is going to be underestimating the true risk. So that's one of the reasons why NZ risk, which is the surgical risk calculator I've developed, has a 1 month endpoint, and it also has a 1 and 2 year endpoint. So you can identify short-term trouble, but also do I have a patient in front of me who is going to live long enough to extract the value of this expensive, painful, protracted operation that we're just about to undergo. One thing my risk calculator does not have, which I hope it will have in the future, is some measure of non-fatal badness, complications. So something like the NISQIP risk calculator has that. But I think there's actually 3 things we need, not one thing. We need short-term mortality, long-term mortality, and some way of describing to our patients about a complicated course. And A, B, C, D. So in that previous slide I showed you, you saw the area under the receiver operating curve. That is a statistic also known as the C statistic, that is a discriminatory statistic. We are also going to talk about calibration. So the A and B, the A is the intercept of the calibration graph, and B is the slope. So we're describing, if I say with my risk calculator the risk of being dead at a month is 5%, that the true risk is 5%. So if you get the calibration is correct, you'll be on that line of 45 degrees. So we will move on to D, which is decision curve analysis, which is some statistics like net reclassification index. But I just want you to think about, primarily at the moment, about calibration and discrimination. And I'll show you exactly what those 2 things do separately in just a moment. So these are the calibration graphs for NZ risk for the 1 month endpoint, the 1 year endpoint, and the 2 year endpoint. And as you can see, the intercept is very close to 0, so A is good. The slope is very close to 1 in all 3 cases, so B is good. And if you look at the area under the receiver operating curve, also known as the C statistic, if it was 0.5, that's like a coin toss. It's useless as a prediction tool. When describing the quality of the ability to discriminate in people who have events, those who die and those who do not, anything above 0.9 is classified as excellent, and I'll show you what that translates to in real life in just a moment. So we're going to be talking about discrimination. So the C statistic, the area under the receiver operating curve, we have a C statistic here of 0.92. This is the table of the 1/4 of the patients from my sample that was used to internally validate and calibrate the risk tools. There's about 90,000 patients here. And you can see that the first 5 deciles, the risk of dying is very low, less than 0.1%, a very, very low risk cohort. Look at the top decile. So my new definition of high-risk surgery in New Zealand is anyone who has an NZ risk of greater than 1.5% is high risk. And look at the right, that's where most of the deaths in New Zealand after surgery are occurring within a month. If you've got an NZ risk of greater than 0.15%, close to 80% of all post-surgical deaths within a month are dying in that group. It is highly discriminating who's going to get into trouble and who is not going to get into trouble as measured by 1 month's mortality. Conversely, if you're in a very low-risk group, perhaps that top half, I would suggest to you that most of those deaths have nothing to do with surgery. If you're 85 years of age and male in New Zealand, you've got a 1 month risk of dying of about 1%. Someone having a cataract operation who's 85 will drop. In New Zealand, if you also do the amount of deaths from the road toll, in each of those deciles you'd expect half a death. So there are other reasons why patients die. So having a C statistic of 0.9 means you can discriminate and triage between high and low risk. I'm only going to talk very quickly about decision curve analysis because I don't think we're quite at this stage where every decision we make is categorising patient into a pathway like, sort of the cardiologist will decide that if you've got a, 5-year risk of having an MI, they'll put you on aspirin. Something like the National Emergency Laparotomy audit, we are talking about it, and we're talking about it with cadenza. But you need a high discriminatory statistic, something with a C statistic of about 0.9, to avoid these kind of problems. When we're talking about complications, say the NSQIP tool, it is very discriminatory for mortality. It is poorly discriminatory for non-fatal outcomes. You will get these kind of categorical errors. So I think when we're triaging our patients, we should carry on talking about the discriminatory characteristics of mortality. Should we be using risk tools that have been derived in overseas populations? So here's an email that was sent to me, just within the last week. It says, asking me a question. One of my colleagues wants to use the NSQIP tool, and I know there are centres in Australia and New Zealand that want to use NSQIP or the surgical outcome risk tool or PPOSM, none of which were derived in or have been, externally validated in large New Zealand or Australian populations. Should they do it? I don't bloody know. God, what am I going to say? The only thing I know is I externally validated the surgical outcome risk tool in a New Zealand population. So I liked the surgical outcome risk tool. It was quick and easy, had 6 very easy covariates. It had statistical properties that meant it was well calibrated and highly discriminatory. And I thought, well, I'm going to base my model on that. But before I did, I externally validated it. And what I showed was it retained its discriminatory properties. It had C statistic of 0.9, but what it was extremely poorly calibrated. So, and the reason is so that doesn't mean that New Zealand, our mortality is 5 times higher than the UK. Our mortality, post-surgical mortality, is far lower than the UK. What has happened is in the original surgical outcome risk tool validation data set, there's quite a lot of bias. If you look at the inclusion criteria, they have a large cohort of orthopaedic patients. They have almost no vascular patient. They have no thoracic or neurosurgical patients. Whereas in New Zealand, with a 360,000 complete coverage of the whole of New Zealand for 2 years, we included everyone, which means that bias translates to very poor calibration. And that is going to happen with all of these risk tools that have been derived overseas. They all have their own peccadillos where do they translate from the UK or from the US to our local populations. So I don't know the answer about NISQIP. The first thing is the NISQIP algorithm is not public, so you cannot locally validate it, and so that's an issue. So, but I have my suspicions. I think we should be cautious. I do want to talk a little bit. We have talked at this meeting about the National Emergency Laparotomy Audit and the Australasian version of that. Which risk tool should we use? Well, if you're in the UK, they have just published their NELA risk calculator that's got about 20 or 22 covariates. It is a very large data set, lots of endpoints. If you're in the UK, absolutely use the NELA risk tool. If you're in Australia or New Zealand, it's not quite so clear. But surprisingly, the SORT, with its 6 covariates, performs better in a UK population than the P-possum with lots of covariates. More is not always better. And right now, what should we do? Well, I don't know. But maybe, I think if you use the NELA risk calculator, it may not be well calibrated, but if you can define local thresholds, it will retain its discrimination statistics, and you could categorise into high and low risk. Any of these tools will do that. They may not be well calibrated. I'd also like to mention that we have the NZ risk, which is a New Zealand non-surgical risk tool. I think is valid in a New Zealand setting. It is not going to be valid in Australia. But Jennifer Riley is doing a PhD at Monash, and she has Paul Miles as a supervisor, is in the process of developing an Australasian non-cardiac risk calculator. So in the not too distant future, there will be a locally validated tool that will be reliable and useful in this setting. So I have mentioned the NISQIP, and there are many things I do like about the NISQIP risk tool, and one is the very, very large data sets they have access to. And also, obviously, 1 month's mortality is not the end of the story. If you're talking to a patient and you have someone who's got moderately high risk, 2 or 3%, the framing of that, yes, well, 3% of people like you might be dead at a month, but that means the assumption, if you frame it positively, 97% survival. Well, we all know the truth of, for some of these high-risk patients, the non-fatal badness that carries on, and the only risk tool that does it really well is NISQIP. The problem I have with it is I look at all these diagnostic codes here, and I think, what does that mean for my patient? What's the impact? We could have a silent MI or MINS. The patient may not even know, or their people caring, or you could get a pneumonia that is going to have a huge impact. I think rather than diagnostic endpoints, as an Australasian audience, I think we are becoming familiar with days alive at home, and I believe that is the endpoint we should model for our risk models that should capture non-fatal badness. Now, I've given you data here from about nearly 15,000 acute laparotomies in New Zealand. I will just preface this by saying that this is from database research, so the inclusion criteria mean it's probably far wider than what you were expecting to see in the laparotomy or Australasian laparotomy audit. So this is a much less risky group than you're talking about in the laparotomy audit. We have a 1 month mortality of just over 4%, and we have a 3 month mortality of about approaching 6. I want you to look at the shape of the histogram for days alive at home at 90 days. So on the far right, this is good. These are people who don't stay too long in hospital. The median, in fact, I'm going to need to get closer to read that. The median is 83 days. These are probably patients who stay in hospital for 7 days, go home, and they make a pretty good recovery. That is framing a good outcome. What I want to know to the patient is, okay, if things go well, that's what's going to happen. The 10th centile is 48 days. So you can infer, you can tell a story. It's not about numbers, it's about telling a story to the patient. What has happened to that patient between the day of their surgery and the 48 days out of 90 they then spend at home? I think we can tell a story about how protracted and complicated and what kind of pathway a patient would get to that position. And in describing that, yes, their predicted mortality might be 4%, but there's a large proportion of patients who have protracted and difficult in-hospital and out-of-hospital stays before they get home. So a checklist for when you're looking at a prospective risk tool. Does it model the correct outcome? I believe the 3 things we need, and no risk tool does it yet, is a short-term mortality endpoint, a long-term mortality endpoint, and some sort of catch-all long-term morbidity endpoint. Is it accurate? Now you know ABC, how the calibration and discriminatory statistics, and I don't think we should be looking, prediction science is now at the state for predicting 1 month mortality. If you don't have a calibration slope of close to 1 and a C statistic that is in the vicinity slightly better or maybe slightly worse than 0.9, it's not good enough. We can do better. And is it generalisable to my patients? Most of us are using overseas risk calculators, and I showed you the issue with the external validation of the surgical outcome risk tool in New Zealand. Be highly suspicious that it is not well calibrated for your local setting. If you have good local data, you might be able to. These tools will discriminate. They'll sort out the wheat from the chaff, but the particular point. You will have to set that locally, and you will need local data in order to do that. So this is NZ risk. The paper describing NZ risk is currently in press at the British Journal of Surgery. It's not quite ready to go to public. The risk calculator there is timed to go live when that is freely available. So in the next week or 2, I hope. But that's what it looks like. It has 8 covariates. So the covariates are age, ASA, cancer, urgency. You put it in an operation and that gets split into specialty and severity. And for a New Zealand setting, it has 2 extra covariates, gender and ethnicity. And my understanding is that Jennifer will be including ethnicity in the Australasian risk calculator. She is also going to be including socio-economic status, and I will also be including that in a second iteration of NZ risk later next year. And many of you will look at this risk calculator and say, it hasn't got my favourite covariate. We've all been talking about frailty. We've all been talking about cardiopulmonary exercise testing. Your favourite serum rhubarb test. You might want BNP, you want troponins. And I'd go back to those calibration graphs. How much more accurate do you want it to be? I've told it can sort out who's going to get into trouble and who is not, and it is calibrated well enough. It's very close to the line of equality. We don't need extra covariates in many settings. This is a general non-cardiac risk calculator. There will be settings where subspecialty, and they will be coming in due course, where maybe we do need those things. But for the general low and intermediate risk patients, it is very, very accurate. And so that's the third page of the risk calculator, how to describe risk. It is difficult. Right? I'm just getting my head around these things myself. But I actually think these tools should be embedded in how we manage our patients in future, because it is predictable who gets into trouble and who doesn't. And I would also like to... these thresholds we set should be based on need. And so the NELA categories, say for high risk, would be calling someone low risk who's got a 5% mortality, less than 5%, is bonkers. I don't see the logic of that. In New Zealand, we could predict who's going to get into trouble. Do we have the capacity to deal with it? Maybe not. But then you can set a threshold based on capacity. If you say, well, we can only take 5% of all the surgical patients into intensive care on day one, well, I'll tell you the number to give you the right volumes. That's what we should be doing, based on capacity and need, not arbitrary thresholds. Thank you very much.
Nick Majorison here. Thanks for listening to Top Med Talk. Now, before we let you go, it's important that we remind you to subscribe to Top Med Talk. That way you'll never, ever miss another episode. Also, if we could encourage you to join us on social media, Twitter, Facebook, LinkedIn, YouTube, pretty much every single social media platform, we're there. Join us. And finally, check out topmedtalk.com. If you go to our website, you can subscribe to email updates. That way we can always tell you where we're going to be, what we're going to be doing, and how you can join us. topmedtalk.com and click on the section marked email updates. Finally, Top Med Talk is proud to act as the broadcasting arm of EBPOM, Evidence-Based Perioperative Medicine. We'd love you to find out more about them as well. ebpom.org is their website. That's ebpom.org. And if you go to ebpom.org/meetings, you can find out about some of the wonderful meetings that we attend and cover across the year here on Top Med Talk. That's ebpom.org/meetings.